Good day, everyone. Before I start presenting a research study, let me take this opportunity to acknowledge my co-author, the chairperson of Science Education Department, De La Salle, Manila, and yours truly, Evelyn Roque Camara from Bulacan State University, a PhD student of De La Salle University, Manila. A research study in this Asian Virtual Conference on Multidisciplinary Research entitled Students' Mathematical Competencies, Basis for an Instructional Module on Selected Topics in Pre-Calculus. In the field of education, the need for a continuous search for methods and techniques and approaches that could best provide the needed appropriate instruction in the most effective and conservative way is limitless, because learning mathematics is a complicated and meaningful process. When students do not comprehend mathematics, they may lose their desire to learn the lesson on that subject, thus affecting their performance. It is therefore the role of the teachers to proactively design meaningful and valuable instructional materials to help students learn more effectively and efficiently. As part of the effort of the Department of Education in the Philippines to respond to the perceived needs of the education sector, the government had pushed through for the implementation of K-12 Enhanced Basic Education Program. This initiative aims to produce more productive, mature, and globally competitive citizens equipped with the essential competencies and skills necessary for lifelong learning and employment. As a result of this major overhaul, the department is in need of effective and beneficial teaching materials that can respond to the needs of the student undergoing the new program in the education system. According to Gregory and Chapman 2013, classrooms are full diverse learners in this second decade of the 21st century. This is an offshoot of globalization in the various fields of human realities and endeavors brought about by breakthrough in communication and information technology. Diversity is a common trait in every classroom. Varying perspectives and backgrounds of young individuals are always a great challenge to every educator. It is therefore incumbent upon teachers to be aware on how the students learn best in order for them to satisfy the needs of a diverse classroom. Following the desire to equip the student with functional skills in pre-calculus, the researchers need to address their diverse learning modes and habits through effective methods of instructional delivery that caters to all individual predisposition to hear despite of diversity. Probably, the monotonous conventional approach of teaching mathematics, which involves the presentation of abstract facts and theorems, contributes to the negative attitudes of the students. To change this attitude of students, Burge 1994 suggested that they should be exposed to alternative methods of teaching. Hence, the researchers designed and introduced a model of learning that deals with pre-calculus in a more learner-centered approach. This is a module. A module is a self-contained and an independent unit of instruction with a primary focus on a few well-defined objectives. Each student can be allowed to study at a pace most effective and at the time most convenient for them. They can also pace their study according to their ability to adapt information presented therein and master the objectives the materials are predicated on according to Pacheco. Since students have different styles of learning and respond differently to similar situations, hence, modular instruction provides the learner with a variety of experiences for learning. This study is deemed significant primarily to the student, for it will give them not just opportunities for learning, but challenges since the student can learn at their own pace. In a modular approach of teaching, teachers are expected to become increasingly proficient in recognizing and supporting students' capacity to become an independent learners. From this, the purpose of the study is to design instructional modules on selected topics in pre-calculus in preparation for the implementation of the K-12 program of the Department of Education. And our research question, first, what is the student's performance in the pre-test and post-test? And last, is there a significant improvement in students' performance in pre-calculus after the implementation of the modules? From this, we arrive at this conceptual framework. In constructing, evaluating, and validating instructional modules in pre-calculus, the prototype shown in the figure was made to utilize as guide in undertaking the study. Collected materials in the pre-calculus like published books, textbooks, K-12 basic education curriculum for senior high school, and internet or web-provided materials were employed in preparation of the instruments and modules. The preferred instrument was validated using the result of pilot tests given to enrolled students of grade 11 in the laboratory high school, which is a compulsory subject of the first semester. The modules were enhanced based on the result of the study. Other factors to be considered like objectives, contents, manner of presentation, and usefulness of the modules were evaluated by the BS Civil Engineering student enrolled in differential calculus during the first semester of that school year. Results from pre-test and post-test of the grade 11 students, together with the feedback, suggestion, comments of BS Civil Engineering students, were used as an input data in evaluating the modules. Scope and delimitation. The researchers focused only on 6 selected topics in pre-calculus. This study aimed to design the instructional modules and selected topics in pre-calculus and designed to be used specifically for grade 11 senior high school of K-12 program. Next, for the methods and materials, research design. Researchers utilized the descriptive quantitative method where only a single group was considered in the study. Students from laboratory high school were chosen to participate in this study, and the research was conducted and data was collected from selected grade 11 students in a state university in the province of Bulacan. The researchers utilized 3 different instruments: first, pre-test, post-test, and instructional modules. For the data gathering procedure, first, permission was sought from the concerned officials and participants. Target classes were selected using convenience sampling. According to Creswell, convenience sampling is a non-parametric sampling design used when the researcher has in mind who would be the best fit participants for the study. This sampling method suits the need of the researchers in considering only the respondent that should be included in the study using set of inclusion criteria. Pre-test and post-test were analyzed and compared. Items in the pre-test and post-test were researchers made. However, these items were validated by at least 3 experts in the field of research. These experts validated the content and the language. Comments and suggestions of the experts were considered and integrated into the final draft. When the final drafts of the pre-test and post-test items were finalized, it was administered to the target participants. Next. In this study, researchers gave students opportunity to solve problems in order to explore materials, concepts, and ideas on the basis of mathematical problem solving activities. These activities were expected to assist students to develop their own intuitions for discovery. Also, during these activities, students thought of problems before they could have gained insight and develop students' mastery of the necessary skills according to Pugali. Hence, in this study, students were to similar opportunities where they could discover possibilities for creative endeavor and problem-solving activities. Further, these activities, which involve reflection on the problem-solving process, became an interesting and a meaningful experience for students. For data analysis, the researchers interpreted the result by using mean score, percentage, and t-test. The mean score was employed to identify the performance level of students on selected topics in pre-calculus. In the same vein, the mean gain was likewise computed to identify the effectiveness of the instructional modules. The student's level of performance was interpreted against the mastery level provided by the National Educational Testing and Research Center. The researchers identified the initial performance of grade 11 students in selected topics in pre-calculus by using researchers-made pre-tests. Data showed that a mean value of 54.77 was registered. The computed value for performance level was 45.64% and is interpreted as poor performance. In this table, Table 2, further discussion of the performance level of grade 11 students. From this table, it could be seen that 18 students or 34.62% had poor performance and 34 students or 65.38% had fair performance. It is worthwhile to note that there are students who have advanced knowledge in topics of pre-calculus. While in Table 3, present the level of students' performance in the post-test scores. Results indicated that poor performance decreased from 18 or 34.62 to 7 or 13.47%, and the fair performance also decreased from 34 or 65.38% to 17 or 32.69%. 28 students have improved their performance from fair to average, satisfactory, and excellence performance. Results showed that mean values of 54.77 and 74.58 was registered for the determination of the mean gain. The performance of the student greatly improved during the post-test. The discrepancy is indicative of the instructional module's effectiveness and the exerted effort guidance given during the tryout. Result further indicated a mean gain of 19.81. The validity of the modules was further established using the result of the pre-test and post-test, utilizing 52 students from the laboratory senior high school. The post-test gain score in this test presented in this table. In this table, indicated that the pretest of grade 11 student revealed a mean value of 54.77 and 74.58 for their post-test, which indicates that learning has occurred. Of that mean value, the standard error of difference between two means revealed a value of 9.37. From that value, the computed t was established at 2.11. Since the t-computed value of 2.11 is greater than the t-tabular value of 1.97 with 102 degrees of freedom at 5% significant level, therefore, the performance of the students significantly improved after the implementation of the modules. The discrepancy is indicative of the module's effectiveness and the exerted effort guidance given by the teachers during the tryout period. Based on the result of the study, researchers led to the following conclusion. First, on the construction and development of instructional modules for grade 11, lesson must be clearly presented in simple language, properly spaced, and with adequate illustrative examples to make learning easier and more convenient to the student. Second, the modules were found effective as shown by the t-computed value is greater than the t-tabular value of 5% significant level, and the significant difference between the grade 11 students' pre-test and post-test result. And last, The developed modules possess a favorable degree of validity as to its objective, contents, manner of presentation, and usefulness. It can be used as supplementary instructional material in pre-calculus for students from the laboratory senior high school. In view of the results and conclusion, the following recommendations are presented for consideration. First, the instructional modules are recommended for piloting or tryout to the senior high of the K-12 program of the Department of Education. Second, lessons that require participatory, interesting, and challenging activities expected to hone students' insight, discovery, and exploration are found to be effective. Next, the instructional modules be re-evaluated using other respondents. Last, another statistical tools can be used in establishing a further validity of the modules while it is being piloted. And this is our references. Thank you for listening.